Hello, and welcome back to More on Maths. In today's video we're covering one of the two types of motion graphs which we learn in A-level mechanics. This is a displacement time graph. The most obvious change, compared to its distance time graph, is that the displacement axis can go into the negative region. We see that here. This is because displacement is a vector quantity, so it has a magnitude, like distance, but also a direction. The direction is determined from either side of an origin point. Thinking back to our kinematics equations, one of them is that displacement over time is equivalent to velocity. Velocity is also a vector quantity because it inherits the direction from the displacement in that equation. So this therefore means that the gradient of our graph in this context is velocity. One thing we can notice is that the steepness of the gradient will determine the size of the velocity. For example, the steeper the gradient, the larger the velocity will be, because the object is displacing more over a shorter time. We've learnt how to work out the velocity at a specific point on this graph, but if we need to work out the average velocity, we can divide the total displacement by the total time. On this graph, the object travels 4 meters away from the origin, then its displacement is constant from 2.5 to 8.5, which means it is stationary at that point because the object's not moving further away from the origin or closer to the origin. Then it travels 4 meters back to the origin, and a further 3 meters in the opposite direction. Finally, it then goes 3 meters back towards the origin. If we total up these displacements, with the original 4 meter displacement being in the positive direction, then we have 4, take 4, take 3, and then plus 3. That's our total displacement. And then our total time is 13.5 seconds. So we divide by this 13.5. In this case though, this displacement is actually 0 overall because we've returned back to the origin at the end. This hence causes the velocity to be 0 overall because 0 divided by 13.5 is 0, because on average the positive velocity has matched the negative velocity and cancelled out. Another thing we can work out from this graph is the speed at any point. To do that, we just take the magnitude of the velocity at any point, as the direction of the speed is irrelevant. The average speed could be calculated from finding the total distance. Instead of adding and subtracting the 4s and 3s, we could simply add them all together, making that positive, as well as this 3. So now our total distance travelled is 8 plus 6, giving us 14 meters. And if we divide by that 13.5, we have an average speed equal to 1.04 meters per second to 3 significant figures. Let's now apply everything we just learned to a question. An athlete is training by jogging in a straight line. The displacement time graph below shows the displacement of the athlete from her starting point throughout her motion. First of all, we need to calculate the velocity of the athlete during her first 2 seconds. So we need to work out the gradient of this portion here. She is displaced by 5 meters across 2 seconds, making her velocity 2.5 meters per second. For B, we need to describe the motion of the athlete during the time between 2 seconds and 5 seconds. So this portion here, we can see she's not displacing at all across as the time increases, which means that she's stationary. Next we need to calculate the velocity of the athlete at 10 seconds. 10 seconds is going to be around here, and we can see the gradient is decreasing at a constant linear rate, so her velocity will be the same anywhere along this line, and we can tell she's displacing 11 meters all the way down to 0 in a matter of 6 seconds. And to 2 significant figures, that is negative 1.8 meters per second. Finally, we have to find the total distance travelled by the athlete during the 14 seconds. And across that 14 seconds, she went all the way up to 11 meters away, and then in this portion she went all the way down another 11 meters back to her original position. So her total distance will be 11 plus 11, which is 22 metres. I hope you found this useful. Feel free to check out the rest of the More Maths channel, where we'll be posting similar walkthroughs in the future, so please consider subscribing so you don't miss a video. Thank you for watching.